I want to revisit this control arm with you guys real quick. I talked a lot about the fitment of this bearing inside the control arm and the different ways that we could potentially attach it, whether it's, you know, a sleeve or welding it or whatever. I don't know if you guys will be able to see, but just outside the bearing, there's a plastic sleeve. That was a piece I was able to 3D print, and I pressed it into the control arm, and then I pressed the bearing into that. Now, if I took that design and cut it out on a CNC machine and got all the tolerances right, to be honest, I think it would probably last a long time. And this doesn't really stop the failures either, but what it should do is allow us time to see it and stop anything catastrophic from happening, like the whole control arm flying off. So what the design is, and I'll probably pop the 3D model up on screen for a second, but what it is it's a two-piece sleeve. So you can see the regular part of the sleeve, which is 2 millimeters thick, and then there's this big shelf on the bottom. Now what that does is when you press, you know, one side will be on the bottom, you'll press that into the bottom, and then you can press the bearing into that. What this eliminates is the sleeve getting pushed through the control arm whenever the suspension compresses. If you think about it, when the suspension compresses, all the force is going up into that control arm. So there's a potential that it could pop the entire bearing or the sleeve out the top of the control arm, and then when it comes back down, you have no control arm, knuckle falls off, and you're screwed. Same thing with the top of the sleeve. There's also a capture piece, which is why it's a two-piece sleeve, so you can press one at the bottom and one at the top, so that when the suspension extends, it's not gonna pull it through the bottom of the control arm. Now, the likelihood of it being pulled through the bottom of the control arm is not as much, there's not gonna be as much force going that way, but it still could happen depending on how fast that suspension unloads. There is still a chance. Now, obviously, this doesn't eliminate the sleeves from totally popping out. Again, this is why it's a two-piece design. If one of them pops out, it's only gonna be in one direction. So either it's gonna go up and the top one's gonna pop out, or it's gonna be pulled down and the bottom one's gonna pop out. This is also why the two-piece design, one of them is longer than the other. The bearing is gonna sit on the lower half of the control arm. So the pocket that the bearing sits in is about 1 inch thick. I think it's 25 millimeters exactly. The thickness of the bearing is about 17 millimeters. The bearing has to be spaced on the bottom half of that, basically flush with the bottom of the control arm, in order to get the clearances we need for the articulation. So at any given moment, the bearing is captured by two sleeves. So if one of them pops out, the bearing is still halfway captured by one of the sleeves. This obviously wouldn't be an ideal scenario for the things to pop out, but it will allow us a safety to be able to hopefully catch it before anything catastrophic happens. Now, on top of the safeties for the sleeve to not pop out, you guys probably won't be able to see it. You might be able to see it on the 3D model. There's a lip on the inside of the sleeve to stop the bearing from moving around. So on the bottom spacer, there's a lip on the inside where when you press the bearing into it, it'll stop it at the right height of where I need it to be to have all the clearance between the knuckle and the control arm. Then on the top spacer, there's another capture lip, which perfectly matches the other one, the 17 millimeter height, and sandwiches the bearing in place. This fully eliminates the bearing from moving around. The only time the bearing is gonna move is if the sleeve is gonna move. Again, not ideal if any of this starts moving around. We really don't want that, but by eliminating the bearing moving with inside the sleeves, we've kind of narrowed it down to one point of failure. Here's the original design, just a sleeve around the bearing. That's what I just pulled out of the control arm that I was testing with earlier. Here's the new bottom half sleeve, and then you won't be able to see it, but that bearing cannot come out of the bottom. Then this whole piece gets put into the control arm, looks like this. Then you take the top one and push it down over the whole thing. Now this top one's gonna be a little bit difficult because for the bottom, whenever you do that, you can heat up the bottom sleeve and cool down the bearing, slip those together, let them equalize, and that should be a nice interference fit. You can then cool that whole piece down with the sleeve and the bearing in it, heat up the control arm, and then push that together. Now for the top, you're messing with an inner tolerance and an outer tolerance. So if I heat this up to fit around the bearing, I'm now not gonna be able to fit it inside of the control arm. This piece will most likely have to just be cold pressed in there, just with a hydraulic press, but the tolerances we're working with, I think will be okay. Since it's just plastic, I actually broke it when I pressed the top of it in, trying to hammer it in there, but you guys can kind of see if I hold it up, the top and the bottom rings that are kind of holding the sleeve in. It's one of those parts that will probably never be noticed, but I'll know it's there, and I think it was cool trying to get this design to work. And honestly, kind of just the safety of me inside the car. If one of those control arms blows off, I'm screwed. Making sure that the sleeves and the bearings stay in there, even just in terms of safety, was definitely important to me, because we could have just run with the sleeve and prayed for the best, but that wasn't really my favorite option. I really wanted to make sure that I had peace of mind knowing that all these parts were gonna stay together. Anyways, not a huge update, but taking that design from a basic sleeve up to what I came up with, which isn't really anything crazier, but I just have a lot of fun designing this stuff. I hope you guys are enjoying these deep dives. We have a lot more pieces of this car to figure out, so definitely look out for more of these videos, and I'll see you guys in the next one.